All right, let's cut the crap and dive right into this shit.
You said it.
We're talking AC/DC, the juice that keeps the world spinning.
Literally keeps the lights on.
People flip a switch and think, boom, that's it.
No clue about the wild-ass history.
Or the crazy science behind it.
Exactly.
So let's kick things off with the War of the Currents.
Oh, yeah.
Edison versus Westinghouse, AC versus DC, total shit show.
Yeah, total clusterfuck. Edison was all in on DC, thought it was the only way to go.
Stubborn bastard.
But Westinghouse, he saw the potential of AC.
Especially for sending power over long distances.
We got it.
But Edison wasn't going to go down without a fight.
Hell no.
Pulled some shady shit to scare people off AC.
That he did. Straight up electrocuted animals with AC.
What an asshole. Trying to make it look all dangerous.
Propaganda at its finest even came up with the term Westinghouse.
Westinghouse.
Yeah, as in getting electrocuted.
Damn. Talk about a smear campaign.
Savage. Right.
So what exactly made AC so much better for long-distance transmission anyway?
Transformers, my friend. That's the key.
Transformers? Like those giant robots?
Nah, not those ones. We're talking electrical transformers.
Okay, so how do they work?
With AC, you can use transformers to crank up the voltage for transmission.
Crank up the voltage? What's the point of that?
Reduces energy loss. That's the beauty of it. Then you step it back down to a safe voltage before it reaches your house.
Gotcha. So those transformers are like the bouncers of the electrical grid, keeping those rowdy electrons in check.
Pretty much. They're the unsung heroes of our modern electrical system.
Makes sense. But why couldn't Edison do that with his DC power?
Back then, DC transformers were a joke. Inefficient, impractical, basically useless.
So Edison was stuck with his limited range. No wonder he was pissed.
His whole empire was crumbling.
So how did Westinghouse finally win this whole electrical pissing contest?
Couple of key moments. First, the 1893 World's Fair in Chicago.
Ah, the Windy City.
Westinghouse snagged the contract to light up the whole damn fair with AC.
Huge publicity stunt.
It was a game changer, showcased the power and efficiency of AC to the whole world.
Must have been a real screw you to Edison.
Oh, absolutely. And then there's Nikola Tesla and his induction motor.
Tesla, the OG mad scientist.
Guy was a visionary, that's for sure.
Didn't he have some pretty out there ideas about electricity?
Oh, yeah, but his induction motor was a masterpiece. Simple, reliable, perfect for AC power.
Game changer for industries, huh?
Absolutely. Factories could finally ditch those clunky, inefficient steam engines and switch to electric power.
Thanks to Tesla and his AC motor.
It was a revolution.
So at the World's Fair and Tesla's motor, AC was starting to take over.
Game over for Edison, pretty much. AC was the clear winner for large-scale power distribution.
So what about those Hungarian engineers you mentioned earlier, the transformer guys?
Oh, yeah. Those dudes were geniuses. Karoli Zbernowski, Odo Blathy, and Mick Zadary.
Try saying that 3 times fast.
Seriously. They came up with the closed-core transformer design, made transformers way more efficient and reliable.
So those Hungarians were the unsung heroes of the AC revolution.
No doubt about it. They paved the way for the modern power grid as we know it.
So no more flickering lights and exploding appliances thanks to those guys.
They saved us from a world of electrical chaos.
All right, so we've covered the basics of AC, the War of the Currents, and those badass transformer dudes.
A good foundation, for sure.
But let's not forget, AC isn't just about lighting up your house.
Oh, it goes way deeper than that.
There's a whole world of high-frequency AC out there.
Where things get really freaky.
We're talking about cranking up the frequency and watching the weirdness unfold.
It's like those electrons decide to throw a rave on the surface of the wire.
The skin effect, right?
Bingo! And trust me, it gets wild.
Sounds like we've got a lot more to unpack here.
We're just getting started.
So we were talking about the skin effect and how things get freaky when you crank up the frequency with AC.
Right, like those electrons are having a goddamn party on the surface of the wire.
We were saying the engineers had to come up with some clever workarounds for that.
Oh, yeah. Remember Litz wire?
Litz wire.
It's basically a bunch of tiny wires woven together.
Like a braid or something.
Exactly. And that forces the current to spread out.
Ah, I see. More surface area for those party-loving electrons.
You got it! It reduces power loss like a motherfucker.
Clever bastards, those engineers. And then there are coaxial cables, right?
Coaxial cables, yeah, those are like the VIP lounges of high-frequency AC.
They're like those metal tubes with a wire running down the
Yep.
middle, yeah.
You got a central conductor surrounded by an insulator, then a shield, then another insulator.
Sounds complicated. What's the point of all that?
It's all about containing the electromagnetic field, keeping it from screwing with other signals.
So it's like a high-security prison for those electromagnetic waves?
Pretty much. They can party inside the cable, but they can't escape and cause havoc outside.
Makes sense. That's why they use them for cable TV and high-speed internet, right?
Exactly. You need those high-frequency signals, but you don't want them leaking all over the place.
Okay, so coaxial cables, Litz wire, that's how you handle those high frequencies. But what about even higher frequencies, like fiber optics?
Oh man, fiber optics, that's where things get really mind-bending.
How so?
We're not even dealing with electrical currents in the traditional sense anymore.
What the hell are we dealing with then?
Light, my friend. Light waves.
Light waves. You mean like lasers?
Kind of.
Right.
The information is encoded in pulses of light, and those pulses travel through the fiber optic cable.
How do they stay inside the cable?
Through a process called total internal reflection.
Sounds complicated.
It is, but basically the light bounces back and forth inside the cable, traveling at the speed of light.
So no more electrons, just photons doing the light speed boogie.
You got it. It's the same underlying physics, but on a completely different scale. And since light travels so much faster than electricity,
Fiber optic internet is crazy fast.
it's like comparing a snail to a goddamn spaceship.
So we've covered the basics of high-frequency AC, coaxial cables, fiber optics, all that good stuff. But what about some other applications?
Oh man, there's a ton of them.
Like what? I mean, I'm sure it's more than just watching Netflix and doom-scrolling Twitter, right?
You bet your ass it is. High-frequency AC is everywhere, man. It's like the hidden force behind so much of our technology.
Give me some examples and I'm all ears.
Okay, how about medical imaging?
Medical imaging. You mean like X-rays?
X-rays too, but I'm thinking more like MRI, magnetic resonance imaging.
MRI, those giant donut-shaped machines that make all those crazy noises.
Those are the ones. They use powerful magnetic fields and radio waves.
Radio waves. That's AC too, right?
You bet. It's high-frequency AC. And they use it to create detailed images of the inside of your body.
So those weird clanging and banging sounds I hear in an MRI machine, that's actually high-frequency AC waves.
In a way, yeah. The machine uses those waves to excite the atoms in your body, and then it measures the signals they emit to create the image. It's mind-blowing stuff, really.
Damn, that's wild. Okay, so high-frequency AC is helping doctors see inside our bodies. What else you got?
How about industrial heating? Induction heating, to be precise.
Induction heating. Sounds like some kind of fancy cooking show.
Nah, it's used in all sorts of industries. Manufacturing, food processing, you name it.
How does it work?
Well, it's based on electromagnetic induction. You use a high-frequency AC coil to create a magnetic field.
Okay.
And when you put a conductive material like metal inside that field, it creates eddy currents.
Eddy currents. What the hell are eddy currents?
They're loops of electrical current that flow within the material, and as they flow, they encounter resistance, which generates heat.
So you're saying you could heat up metal just by waving a magic AC coil at it?
Pretty much. And it's incredibly precise. You can heat up very specific areas without affecting the surrounding material.
That's pretty damn cool. What do they use it for?
Tons of stuff. Melting and refining metals, hardening steel, even sealing plastic packaging.
I had no idea. So we got high-frequency AC, helping doctors see inside our bodies, and engineers melting metal with invisible forces. Pretty versatile, huh?
And we're just scratching the surface here.
There's more?
Oh yeah, a lot more. There's wireless power transfer, radio frequency identification, the list goes on and on.
Hold on. Wireless power transfer, you mean like those charging pads for smartphones?
That's one example, but the technology has way more potential. Imagine being able to power your whole house without any wires.
Oh, that's some futuristic shit.
It's coming, sooner than you think.
But what about radio frequency identification? What is that?
RFID, those little chips they put in credit cards and pets.
Oh yeah, those things.
Those chips are basically tiny antennas that talk to RFID readers using radio waves.
Which are a form of high-frequency AC, right?
Bingo! It's all connected.
Damn, this high-frequency AC is everywhere. I'm starting to feel like I'm living in a sci-fi movie.
It kind of is. When you think about it, high-frequency AC is quietly shaping our world in ways we don't even realize.
All right, I think we've covered enough ground for one episode. We've gone from the skin effect to fiber optics to all sorts of amazing applications of high-frequency AC.
Yeah, we've been through a lot.
Okay, so let's wrap up this deep dive into the wild world of AC.
It's been a hell of a ride.
From Edison's shady tactics to those Hungarian transformer wizards.
And that crazy skin effect with high-frequency AC.
Shit gets weird when you crank up the frequency.
You said it.
But for this last part, I want to explore some of the more unexpected applications of AC.
The mind-blowing stuff.
Yeah, the things that make you go, holy shit, I had no idea.
You want mind-blowing. How about using AC to unlock the secrets of the universe?
Wait, what? Explain that shit.
Particle accelerators, those massive machines that smash atoms together.
Those things are huge, like miles long.
They rely on AC to create those incredibly powerful magnetic fields.
To accelerate particles to near the speed of light, right?
Exactly. It's basically a giant electromagnetic slingshot.
So those atom smashers are running on the same basic principle as my toaster.
Well, it's a bit more complicated than that.
I bet.
But yeah, the underlying principle is the same. Manipulating AC currents to create those insane magnetic fields.
And by smashing those particles together, they can recreate the Big Bang.
Pretty much. They're trying to understand the fundamental building blocks of the universe.
Damn, AC is literally helping us understand where we came from. That's heavy stuff.
It's pretty amazing.
Okay, so AC is probing the mysteries of the universe. What else you got?
How about futuristic propulsion systems? Space travel.
Spaceships powered by AC. What is this? Star Wars.
Not quite lightsabers and hyperspace, but we're talking ion propulsion.
Ion propulsion.
Using AC to create an electric field that accelerates ions, creating thrust.
So instead of burning rocket fuel, you're shooting out a beam of charged particles.
Exactly. It's way more efficient for long-duration space travel.
AC taking us to the stars. I'm loving this.
The future of space exploration is electric, my friend.
All right, hit me with one more mind-blowing application.
How about revolutionary medical treatments? Electrochemotherapy.
Electro what now?
Electrochemotherapy, it's a cancer treatment.
Sounds intense.
It combines chemotherapy drugs with high-frequency electric pulses.
So you're zapping cancer cells with electricity?
Kind of. Those electric pulses create tiny pores in the cell membranes.
Making them more vulnerable to the chemo drug.
Exactly. It's a way to target the tumor cells directly, making the treatment more effective and reducing side effects.
Damn, that's incredible. So AC is helping us understand the universe, explore space, and fight cancer. This shit is everywhere.
It's pretty remarkable when you think about it.
It is. It's more than just a way to power our homes. It's driving innovation, scientific discovery, even pushing the boundaries of medicine.
AC is the unsung hero of modern civilization.
Well said. All right, folks, that wraps up our AC Odyssey. We've covered a lot of ground, from the basics to the truly mind-blowing.
It's been a blast.
And I hope you've learned some shit you didn't know before. So next time you flip a switch, plug in your phone, or fire up your computer, take a moment to appreciate the power of AC. It's the silent force that's shaping our world, one electron at a time.